Hey guys, today we're going to talk about two-way tables. I know Florida Virtual calls them frequency tables, but I prefer to call them two-way tables. All right, so basically, when you collect bivariate data, you can always display bivariant data on a two-way table. So the definition of bivariant data is on your screen. It says data representing two variables, and this information doesn't overlap, and it can be represented in a two-way table. So for example, let's say I had a survey. I asked people, what's your favorite pizza topping? And my choices were cheese, pepperoni, or both. So some people are going to like cheese and not pepperoni. Some people's going to want pepperoni and not cheese. Some people don't like either, and some people like both. So we can display that information on a two-way table. So whatever our categories are, so we're talking about people who like cheese. Well, what's the opposite of liking cheese? They don't like cheese. So that's these categories right here. Likes cheese, don't like cheese. And then other people like pepperoni, or if you don't like pepperoni, right? They're kind of opposites. So if you notice on the bottom here, this row is always going to be our total column. So there's a total of 26 people that like cheese. So you read it this way. There's a total of 11 people who don't like cheese. So the total number of people surveyed was 37. Now, if you go this way, so this is a column. Did I say that was a row? No, I said this was a row. All right, so these are a column that holds up buildings. They go this way, right? Well, if you go across, these are rows. So the total number of people that like pepperoni is 27, and the total number of people that don't like pepperoni is 10. So then, once you have all that data, you can figure out the number of people that, when it says, my pen turned off, I'm trying to turn it back on, who likes cheese and not pepperoni. So you go to the column that says like cheese, right here, does not like pepperoni. That's where those 8 people go, right there. People who like both. So we go to people who like pepperoni, people who like cheese, and that's where those 18 people go. People that like pepperoni, which is this row right here, but does not like cheese. So we're going to come right here, and that's where those 9 people go. And finally, for neither, does not like pepperoni, does not like cheese, 2 people right there go in that situation. Okay, so that's basically how you make and you read a two-way table. So it says Courtney surveyed her Glee club to see which t-shirts to order for the fall competition. So we have information about green shirts and orange shirts. So some people want green or they don't want green. Some people want orange or they don't want orange, or some people like both and some people like neither. So we can take that information and put it on this two-way table. So notice here we have light green, doesn't like green, and then people that like orange and doesn't like orange. Okay, so if we want people who like a green shirts but not orange, so green shirts are here, and does not like orange shirts. These are 15 people who like green and does not like orange. How about people who like orange shirts? So right here, I'm looking for likes orange shirts. I'm looking at this row, but not green. Well, these people right here do not like green. So those 8 will go right here. How about the people who like both? So likes orange, likes green, those 11 go here. And then how about the people who like neither? Does not like orange shirts, does not like green shirts, and that's 5. So now we want to get our total in this column. So the number of students that like green shirts is 26. Going down, the people who don't like green shirts is 13, right? And then we go to our orange shirts. We go on this row. People who like orange shirts is 29. People who do not like orange shirts is 20. And so both of these this row and column should both equal the same total, which is 49. which makes me realize that something's wrong because 26 plus 13 does not equal 49. It equals 39. Oh, because I added wrong right here. No, I didn't. Oh, I added wrong here. This is, oh my goodness. This is not 29, it's 19. Sorry, guys. See, but that helped me catch my mistake. Did you notice that? I knew those columns and the row and the column had to equal the same amount, and I found my mistake because I knew that they didn't both equal 49 because they're supposed to both equal 39. So 39 people were part of my survey. Now that question isn't anywhere. How many people did she survey? But I figured it out when I created and filled in my two-way table. All right, so let's look here. Oh, and that's what I had. So we got it right. We checked our answer. Yes, we're correct. All right, so let's create our own two-way table. So let's look at what our two categories are. We either have people who listen to music. What would be the opposite? Don't listen to music. So we're going to say these people like music and these people do not listen to music. Does that make sense to you? All right, our last column is our total column, and our last row is our total row. Now we have people who either watch TV, right? I love TV. Or what's the opposite of that? I don't like or watch TV. Okay, so let's figure out where. You guys try this on your own. See if you can figure out where those numbers come and then those numbers go, and then come back and check your answers. All right, so what about the people who listen to music? So these people right here listen to music, but they do not watch TV. Those 6 go there. How many people watch TV? So first row here, but do not listen to music. Only 1 listens to music right here and watches TV. Those are 4. And then how many people does not listen to music? So this column, but does watch TV. And there we have 12. So now we're going to go in this column and figure out our total of 10 people love music and 13 people don't listen to music. Can you guys imagine? These 5 people watch TV and these 18 people do not watch TV. So once again, we got to make sure this is the same total for my column and my row. And this time I'm right. Yay, I know how to add. All right, so did you guys get that? I hope you did. All right, you guys try this one as well. Carson's going to take a poll to see which sports. I have something over my words. I can't read that, but I'm sure you can. All right, so we're going to see people who attend lacrosse. So we're going to say this is just easier. They watch lacrosse. Or what's the opposite? They don't watch lacrosse. And then the last one's always our total. And then this is either people who attend, we'll pretend it says love. Ooh, that's not what I wanted to write. Track, and then those are people who don't attend track. And once again, our last row is totals. All right, so we'll attend lacrosse, but not track. So lacrosse people are here, not track is right there. Those 14 people go to lacrosse and not track. All right, we'll attend both. So these people go to lacrosse, these people go to track. So there's 17 that do both. Will not attend either. No lacrosse, no track is 30. And will attend track. Now that's different than one of the other ones. Will attend track. It doesn't say anything about lacrosse, so we can't guess. So of the people, so we're going to go this way on this row. The people who attend track all the way here at the end, that's the total number of people that attend track. So now we have to know this number just by doing some subtraction, right? So first thing I'm going to do is find the people who do attend lacrosse. So a total of 7, 8, 9, 10, 11, that would be 31. Now, if 38 total people attend track and 17 of them also attend lacrosse, then the difference of that is going to be our other category. So that's going to be 21 right there. Okay, so the total number of people who do not attend lacrosse, we're going to go straight down and add and get 51. And then when we add 14 plus 30, these 44 people do not like track. So then to make sure I had this number right, I got to make sure my total column and my total row is the same number. So I'm getting 82. And this equals 82. So I know the answer is correct. Okay. Now the question is, what is the relative frequency of students who will attend both lacrosse and track? So what is relative frequency? Relative frequency is the number of times something occurs divided by the total number of answers. So we want to know the relative frequencies of students who attend both lacrosse and track. So relative frequency is out of the total. So that means our denominator is 82. Our denominator is 82. And how many people attend both? Well, it's these people right here. 17 people out of the total attend both. Now, you can either leave your answer as a fraction, and that's already simplified, or you can turn it into a decimal. We would divide 17 by 82, and I get 0.21, and I could also write it as a percentage by moving that decimal 2 places to the right, and I would get about 21%. 21% of the total people surveyed attend both. So that's how you do relative frequency. It's out of the grand total. All right, let's look at this one. Andrew's survey on homework habits is represented in the two-way table. So they've already filled out the two-way table for us. Now the question is, what is the relative frequency? So that means out of the grand total, and here's the grand total. So I know my denominator is 23, who do not listen to music or watch TV while doing homework. Do not do either. Does not listen to music, does not watch TV, and these are 12 out of 23. So a fraction is an appropriate answer, and that one's already simplified. Or I could also answer with a decimal. 12 divided by 23 is 0.52. Rounded to the hundredths, or a percentage. I would move my decimal 2 places to the right, and I would say a little over half of them, right? A little more than 50% of people do not watch TV or listen to music while they're doing homework. And that's how you find relative frequency. So this time it says Andrew's survey on homework habits is represented in the table. This time we want to know what's the relative frequency. So once again, we're using 23 as our denominator of people who listen to music but not watch TV. All right, so listens to music this way, does not want to watch TV this way. So we're talking about 6 people who listen to music but do not watch TV while they're doing homework. So we're going to find what is 6 out of 23. I can leave it like that, 6 out of 23, or I could divide 6 by 23 and get 0.26, or move that decimal 2 places to the right and say 26% of these students listen to music but do not watch TV while doing homework, 26%. All right. Now this time we're going to look at what is called row relative frequency. So Omar took a poll of members of his art club to see which event they would like to participate in next year. His results are shown in the table. So we're talking about people who are going to do the sculpture fair, or the opposite would be no sculpture fair, and then students who's going to attend either the painting expo or not attend the painting expo. So this time we want row frequency. Now remember, rows go this way. The opposite way is columns. So we want to know the number of students who would like to participate in painting, but not sculpture. So we're looking for students, the total number of students who are going to participate in painting. Well, this is what we're looking for. How many total students are participating in painting? So our grand total is 12, that's our denominator. But we also want to know how many they're not participating in sculpture. So of those 12 people, 5 are not going to participate in sculpture, in the sculpture fair. All right, do you understand that? So you got to get the grand total of the first criteria and then get your numerator. So we're either going to leave our answer as 5/12, or I'm going to divide 5 by 12 and round it to the nearest hundreds. I get 0.42 because the next number would be a 6. Or I would say that about 42% of the students who are going to be in the painting expo next year will not go to the sculpture fair. All right, now we can also do column relative frequency, right? Column relative frequency. Now our columns go this way. So it says this times we're going to find the column frequency of the numbers who want to participate in both the painting expo and the sculpture fair. So the first thing we're going to look at, the first criteria is go into the painting expo. How many students? Wait, that's not one of our columns. Oh, so since our column is not painting expo, our column is sculpture fair. So I need the total number of students who are going to participate in the sculpture fair. So that means I'm going this way. So this one up here was the first criteria, but it happened to be because that was one of the rows. This one is actually the second criteria, but since we're talking about columns specifically, you have to use the subjects of the columns, and in this case, it's sculptures. So the total number of students going to participate in the sculpture fair is 16. That's our denominator. And the ones who also are going to do painting expo is 7. So our column frequency is 7 out of 16. I can leave it like that, or I'm going to type, I'm going to round it to the nearest hundreds and say about 0.44, or I can turn that into a percentage and say about 44% of the students that are going to the sculpture fair are also going to participate in the painting expo. All right, so anyway, hope that's clear. Now this says, in order to determine whether you're going to find a row or column relative frequency, you need to read the question carefully, because it's not always going to say the word row frequency or column frequency. You have to read these carefully. So basically what we're doing is finding the conditional frequency. The conditional frequency is when it's not out of the grand total of everyone, it's only the total of one of the categories, like we just did on the last slide. That is conditional frequency, but they were making it easier for us because they were using the words row and column. So we got to read carefully, okay? So let's look at the first example. If a student does not listen to music while doing homework, what's the probability that he or she will also watch television? All right, so what's our first criteria? If a student does not listen to music while doing homework. So we're talking about only these 13 students who do not listen to music while doing homework. So that's my denominator. What is the probability that he or she will also watch TV? Well, how many students watch TV but do not listen to music? Only 1. 1 person out of 13. So I can leave it as that, or I could divide 1 by 13, and I get about 0.08, or I could say about 8% of students who do not listen to music while doing homework watches TV. Okay, so it says first consider the number of students who listen to music, which is 13, and then only the students who watch TV within that group. Hi. All right, hopefully you guys understand that. So we're still finding conditional frequency, but this time it didn't tell us we were looking for column frequency. All right, so let's look at the next one. It says Yarrett surveyed the students in his homeroom to find out, I'm sorry guys, I have something right. Oh, I can move it, there we go. To find out who prefers certain classes. His results are shown in the table. So the first thing it says is if a student likes English. So are we talking about every single student on this two-way table? No, we're not. We're only talking about students who like English. So we're going to go to this row and we're going to find out, we're talking about 21. Yes.
That's okay.
Yes.
Okay, I just
Oh,
didn't-
I'm sorry.
I just didn't want you to have been using it. Okay.
Yeah. Okay, so our denominator is going to be 21 on this one. And then it says, what is the relative frequency that this student also likes history? So we're talking about these 21 students that like English. How many also like history? Well, 9 of them like history out of 21. So we can leave our answer. Actually, we can simplify this, right? These are both divisible by 3. So we're going to write 3 out of 7, which is simplified. And then we can divide 3 by 7 and we get about 0.43. And we can round that to about 43%. So we have to read carefully, right? We have to read carefully. Yarrett surveyed the students in his homeroom to find out who prefers certain classes. Based on his survey results, how many more students like English versus history? How many more? That's a subtraction question in math, isn't it? How many more students like history? So how many total students like history? 21. And how many total students, I'm sorry, how many, those are the students that like English, excuse me. And how many students like history? Well, there's 14. So how many more in math? That's a subtraction problem. So 21 minus 14 is 7. 7 more students like English than history. All right, so the table shows the number of students in a class who take French and or take Spanish. So these are from your questions that you're going to have tomorrow on Tuesday about two-way tables. So basically, we're just trying to figure out what this missing number is right here. So how would we figure out what this number is right here? Well, we have 2 choices, don't we? Since this is the total number of students who did not take Spanish, couldn't we subtract those who did not take French also from 42? We could. And the other way we could find that number is because we know that 47 students took French and 15 also took Spanish, we could subtract 15 from 47 and we'd still get the same answer. So you have 2 different ways to figure out that missing number. The two-way table shows the number of students in a school who bring their lunch and or who ride the bus. So here we have another, how many more bring their lunch than ride the bus? So how many more in math? That always means subtract. So how many more bring their lunch? So how many students bring their lunch? 95. Then ride the bus. How many students ride the bus? 75. So the answer to that question is 20 more bring their lunch than ride the bus. 20 more. All right, the table below shows the number of students in a school who like rap and or hip hop music. What is the relative frequency by row of students who do not like rap or hip hop? All right, so who do not like either. So we're looking for a row. We're not looking for a column. So that means we go this way. So who do not like hip hop? Well, that would be 31 students who do not like hip hop. And they also want to know who do not like rap. So of these 31, 21 do not like either, correct? So we can leave it in that form. Or we could divide 21 by 31 and we could get about 0.68. It would round up to about 68, or we could turn it to a percentage And say about 68% of the students who don't like hip hop also don't like rap. Ella surveyed the students at her school to find out if they like math or science. If a student likes science, only the students who like science. If a student likes science, which is 63 of them, what is the probability that a student does not like math? First of all, I can't imagine students not liking math. That doesn't make sense to me. But of the 63 people who like science, 22 of them don't like math. So we can leave it in that form, or we can divide 22 by 63, and we could say 0.35 or about 35% who like science do not like math. All right, now here, this is, like I said, these are on your little quiz for frequency tables, or two-way tables is what they're called. So we want to find out who made the best two-way table. Was it Emily, Will, Sarah, or Maria? So we're looking for a total of 32 students like babysitting. So babysitting would be BT. Babysitting, we need a total of 32.
Your attention, please. Would all track members please go to the gym? All track team members, please go to the gym.
All right, so both of these are contestants, right? Emily and Maria both know where 32 goes because these are the students who like babysitting. 21 students that like babysitting do not like mowing lawns. 21, well, it looks like Maria's got it. 21 of these 32 do not like mowing lawns. 16 students like mowing lawns, so who like mowing lawns, so that would be right there. There's their 16. And 12 do not like to do either. And so Maria has it. She is the one who came up with the correct two-way table. All right, you guys, I hope that helped. That's what you're doing Monday and Tuesday. Those are the kind of questions, obviously, this is Monday's lesson. So Tuesday, you're answering questions about those on your own. And then you're going to have a practice test. And then we're going to meet on Thursday for your test review. And then your test is on Friday. All right. I will see you guys on Thursday. Make sure you come to that meeting. All right. Everybody have a great week, and I'll see you on Thursday.